Okay, so we are up to 222. Some general rules for you just to get started here. Memory tool. All students take calc. This is a memory tool to help you understand this without having to do this every time. But I want to teach why this works. So, this says in the quadrant 1, everything's positive. Sine, cosine, tangent. Why? Because my adjacent, opposite, and hypotenuse are positive. There's no way I can have a negative. And this point right here is positive x, positive y. Positive, positive. Let's go on to quadrant 2. Sine is the only thing positive. Why? Opposite over hypotenuse. Positive. What would cosine be? Negative over positive. That'd be negative. Tangent would be opposite over adjacent. Negative. That's why sine is the only thing positive in the second quadrant. Going on to the third quadrant. Take stands for tangent. Tangent's the only thing positive. Opposite over adjacent. You can see that that's true. So let's look at sine. Opposite over hypotenuse, negative. Cosine. Adjacent over hypotenuse, negative. The coordinate point would be negative x, negative y. Quadrant 4. Cosine is the only thing positive according to this memory tool. Let's look at y. Cosine is adjacent over hypotenuse, positive. What would sine be in the fourth quadrant? Opposite over hypotenuse, negative. What would tangent be? Opposite over adjacent, negative. So you can see that this is true. Now we're going to use some of this to actually calculate some of these problems. Okay, so this problem on the board here is reflecting something you're going to have to do on your homework. It's going to say what point corresponds to an angle of 165. Now notice we were working with 30, 60, 90s, 45, 45, 90s, where you can just use those rules to figure out what the lengths of the triangle is. Now, we spinner 165, that's what this is saying. The implied idea is that we're dealing with a unit circle, which tells us that our spinner's got length 1. We spin it. How do we figure this out? Well, we got to create our triangle by coming back to the x. Remember, that's an always rule. Meaning, our reference angle is 15 degrees. Now, if we remember something from a previous lesson, I think it was 113, we can use trig to figure something out like this. So here's my y value, because that's going up. So I got opposite over hypotenuse. That's why I'm using sine of 15 degrees is y over 1. If I look up sine of 15, oops, got to turn the darn thing on. Sine of 15 degrees is 0.258. We'll call it 0.26. So this is 0.26. Now you can just see y over 1 is just y, so y equals 0.26. Now I could use Pythagorean theorem and go a squared plus b squared equals c squared. But I'm going to use this. Cosine, here's my x. Remember, x has to be negative over here. This isn't going to spit out a negative. So I need to just know that. So cosine of 15 degrees is 0.965. So this is 0.965. We'll just call it 0.96. So x equals 0.96. But it's got to be a negative. And there we go. One way to do it. But then all of a sudden, I'm going to give you a nice little handy-dandy formula that works a lot better than what I just showed you. But I want to show you some more tricks in your toolbox. This is just saying take your spinner, your theta, cosine of 165, sine of 165. Now we round it a little bit over here, so it might not be perfect. But if we take a look at this, and we just go cosine of 165, we get negative 0.96, and then sine of 165, 0.26. So as you can see, different ways to do this. Clearly this formula is better. So that's what I wanted to show you. Give me a second. All right, so here's some problems that are going to mess with you a little bit. Start out with some basics. Sine is 4/7. So let's stop right there. Take a look at our picture. We know that sine is opposite over hypotenuse. So that's why I drew my picture like this. This is my opposite. This is my hypotenuse. This is a non-unit circle, so we're making an adjustment. And I'm just going to kind of kickstart this because we're on a tight schedule here. If I go a squared plus b squared equals c squared with these units, I would get the square root of 33 for that distance. So with that helpful hint, now I can figure out other things. So now this says, all right, find sine of your original angle plus 180. Well, here's my original angle. If I added 180, it would take me right here to this picture over here. This reference angle is the original angle plus 180. So if this was like 30, this would be 210. But we don't know what it is, so we're just going to represent it over here. And now I've got this other drawing. So what would sine be over here? Opposite over hypotenuse, -4/7. What about this one? Take the original angle, this one, subtract it from 360. So this is 360 minus our original angle. So let's just say it's 30. It isn't 30, but let's just say it is. That means it'd be 330. So I'd have to go all the way to 330. That's why I'd have to draw my drawing all the way over here. It's 360 minus my original, which would take me all the way into the fourth quadrant. And so now I've got the same drawing over here. My reference angle is 2 pi minus theta, which is just 360 minus my original. So again, my original is right here. If I subtracted that from 360, it's whatever's left, and it would take me to this drawing right here. So this is my reference angle, represented by this, and now I gotta find sine. Opposite over hypotenuse, -4/7. This one's quite simple because cosine is just adjacent over hypotenuse, and if you know by Pythagorean theorem what your adjacent side is, boom. Now they're going to get tricky and they're going to say, all right, take your original angle and go 180 minus this. So if I said, okay, 180 minus this would be right here. So that's what would be left. So for example, if that's theta, it's 30, that'd be 180 minus 30, which would be 150, leaving me with that. Okay, so with that in mind, now I've taken this drawing, duplicated it over here, and now I need to find cosine, which is adjacent over hypotenuse, -√33/7. So it's a little bit of a mental exercise, but I think you guys got. All right, so now they're going to introduce us to what they're going to call special right triangles. We've already been introduced to that, but not necessarily unit circles, meaning our spinner can be something other than 1, giving us a little freedom. This is telling us how far to spin the spinner. Well, that's 30 degrees times 5 is 150 degrees. So I start here, be a little careful, so your drawing looks a little accurate. That means my reference angle is 30. Finish your triangle. I'm going to go with the easy idea of my short side being 1, making this 2, and that make this the square root of 3, but this has to be negative, positive, and of course my spinner is always positive. So what's sine? Opposite over hypotenuse. Now you can check that with your calculator. If you're on a test, you could type this into your calculator and it would just spit out 0.5, but I'm going to be looking for your quiz and tests for work, because they want to practice the spinner, drawing your triangle, and all that. What does this mean? It means go down. So, all right, down how far? Well, that's 60 degrees. 8 times 60 is 480. If we take 360 off of that, we got to go a full circle, then an additional 120 in the negative. So I go around 1. Then I keep going 90 plus 30. Yes, this is 30, but that's not my reference angle. My reference angle is always sandwiched between my spinner and my x-axis, so this is 60. Finish your triangle, meaning that's 30, 90. I'm going to stick with my dimensions of 1, 2, square root of 3, and then I'm going to think about negatives. That's negative, negative. So what's cosine? Adjacent over hypotenuse, negative 1/2. Now, I'm going to introduce this formula to you, even though there's nothing on your homework that deals with it, but I want you to start thinking about this very famous Pythagorean identity. That's what it's called, a squared plus b squared equals c squared. Now let's just see what happens. So, essentially, we're going to go sine, give me a second here. All right, I just wanted to eliminate a little confusion. I'm going to apply the 150 degree spin, this spin. I could have used this one, but that was a little chaotic and I didn't have room to work. But this is saying take sine of 150 degrees and square it. That's what this is saying. Now, I'm just using 150 because I got this example right here. Now, what did we say sine of 150 degrees was? 1/2. So this corresponds with that. What is cosine of 150 degrees? Well, cosine would be adjacent over hypotenuse. That's where I got the negative square root of 3 over 2. Now we're going to prove that this works. So that would be 1/4 plus, if I square a negative square root of 3, I get 3/4 equals 1. And we go, aha, this does work. And that's all I wanted to show you, just to introduce you to the infamous sine squared plus cosine squared equals 1. Okay, so as you can see, this unit's going to introduce you to some tougher compositions, and let's just attack it. So you got f of x equals that, g of x equals that. Now they're going to ask us to do some nifty little things. It's not too difficult, you just follow the instructions. This is just subtract g from f. So I'm going to take 2x cubed plus 3, that's f, and I'm going to subtract g. So x squared minus 4. Be careful, distribute. So that's really negative x squared plus 4. And then that's 2x cubed plus 3. So I'm just going to rewrite that as 2x cubed minus x squared. 3 and 4 is 7. Not too bad. This one, well, take f of x, 2x cubed plus 3, divided by g of x, x squared minus 4. Now you got to be careful here, because this could be factored into x minus 2, x plus 2, but you can see that's not going to cancel because I can't factor this, so we're done. Didn't need to factor it. Now this is your classic inside out, so we've got to take g of x and put it into f. So that means I got to take all of this and put it here. So I'm going to give myself some space because this is where it gets tougher. So I got to take all this, put it in here, which means I got to go 2 times x squared minus 4 cubed plus 3. Well, I got to do it. So x squared minus 4 times x squared minus 4. I'm going to FOIL this. X to the 4th, negative 4x squared, negative 4x squared, negative 8x squared plus 16. Now I still got to multiply that by itself one more time. So I'm going to hit this with this, this, and this. So I get x to the 6th minus 8x to the 4th plus 16x squared. Now I got to take that negative 4 and do the same thing. So, and I'm going to line some things up here because I can see that this is like terms with this. Then I get 32x squared, just putting my like terms together, and then minus 64. If I just look for like terms, I'm going to end up with x to the 6th minus 12x to the 4th plus 48x squared minus 64. Now you can see why these are tougher. All right. I think you guys get the idea here, so I'm not going to show you this just to save a little bit of time. I've only got about a minute, so I got to really speed this up. 54 breaks down into 27 and 2. What's the first number less than 11 that 3 goes into? 9. What's the first number less than 7 that 3 goes into? 6. That's why I broke this down. So this is 3x cubed, because 9 divided by 3 is 3. Here, y squared times the cubic root of everything that doesn't break down. This one, x1, y1, x2, y2, distance formula, plug it all in, reduce. I'm sorry, I ran out of time, but I think you get the idea.